Hello math people, welcome back to chapter 5.5, Trigonometric Equations. Today we're going to be doing the third and fourth objectives, so that's using trig identities and factoring trigonometric polynomials, and to use inverse trig and the properties of sine and cosine to solve for all solutions. If you want a refresher, go look at the last video that I posted, it's also in the playlist, but basically we went over these. So we're just going to start right into our new material. So a quick little review on factoring, right? So if we wanted to solve the equation x squared plus x equals 0, we would factor out an x and get x times x plus 1 equals 0. And we would conclude that x equals 0 or x equals negative 1, right? But what if we had sine squared theta plus sine theta equals 0? So we're going to try to think of sine squared theta as the x instead. So what you may have done would be, like for this one, you might have done, okay, so sine squared theta equals negative sine theta, and maybe you would have divided by sine theta to get sine theta equals negative 1, but you're missing out on some of the solutions, right? So this only tells you that sine theta equals negative 1, but if sine theta equals 0, then this also works. So we can't divide. We're going to have to factor just like we did up here. So if we factor out a sine theta, we're going to get sine theta times sine theta plus 1. And so we're going to get sine theta, excuse me, I'm going to put that down here. So we conclude that sine theta equals 0. Excuse me, this whole equation equals 0. So either sine theta equals 0 or sine theta plus 1 equals 0, which means sine theta equals negative 1. And we're going to try to find all the values on our unit circle that satisfy this, and we're going to get look on your unit circle for this, but theta is either equal to 0, pi, or 3 pi over 2. And those are the values that solve this equation. So another example with x instead. So what if we were trying to solve 2x squared plus 3x plus 1 equals 0? So we could do the AC method. So I'm going to multiply. So this is ax squared plus bx plus c. A times c is equal to 2. And we want factors of 2 that add up to 3. So 2 and 1, I'm thinking. So we have 2x squared plus 2x plus 1x, and that's this thing here, plus 1 equals 0. And we're going to get 2x times x plus 1 times x plus 1. So we have 2x plus 1 multiplied by x plus 1, right? And equals 0 equals 0. So this means that x equals negative 1/2 or x equals negative 1, and those would be our two solutions, right? So again, we're going to try to solve this equation, and we're just going to treat sine of theta like x. So just like we factored before, right? So we can multiply a and c together. So 2 times 1 is 2. And we want factors of 2 that add up to 3. So 2 and 1, I'm thinking. And we're going to get 2 sine squared theta plus 2 theta, or excuse me, 2 sine theta plus sine theta plus 1 equals 0. And again, this is the same thing we had before. I'm not going to go over all the steps, but we would factor this as 2 sine theta plus 1 times sine theta plus 1 equals 0. So we can either have sine theta equal negative 1/2, or we can have sine theta equals to negative 1, right? Now just try to find the values in a unit circle that add up to those, or that evaluate to those, right? I'll give you a moment. And we conclude that the answer is theta is equal to, for negative 1/2, we can either have 7 pi over 6 or 11 pi over 6. And then for negative 1, we only have 3 pi over 2, and these would be our answers. Hooray, okay. So one more example, we're going to solve sine squared theta minus 4 sine theta plus 3 equals 0. So a times c is 1 times 3, which is 3. We want two factors that add up to negative 4. I'm thinking negative 1 and negative 3. So we have sine squared theta minus 3 sine theta minus sine theta plus 3. We can factor out a sine theta from this one to get sine theta minus 3. And we can factor out a negative 1 from here to get sine theta minus 3. And we're going to pull out this common factor right here. We're going to get sine theta minus 1 times sine theta minus 3. And so we're going to conclude that sine theta equals positive 1, excuse me, or sine theta equals 3. But we know that sine theta can only be at most 1, right? So it goes up and down, but its maximum value is 1, right? So 1, negative 1, sort of what the sine graph looks like. That's cosine. And so we cannot have sine theta equals 3, so we're going to ignore this. And we just want to solve for the theta values where sine theta is 1. And this is only going to happen on this interval right here from at pi over 2. So our next example, we're going to solve cosine of x minus 2 sine of x cosine of x equals 0. So you might be seeing this and your brain might be going off and going, oh, I know this identity. This is what? Sine of 2 theta, right? But that would be a mistake, right? Because that's not really going to help us at this point. So instead of multiplying or trying to find an identity here, what I'm going to do is I'm going to factor, right? Because we have a cosine of x term that we can take out of both, and we'll get 1 minus 2 sine of x, right? So cosine of x times 1 minus 2 sine of x equals 0. So either cosine of x equals 0, and I'm going to say on the interval 0 to 2 pi. So we're going to say cosine of x equals 0, or sine of x is equal to what? So we have 1 minus 2 sine theta, or 2 sine x equals 0, which means that 1 equals 2 sine x, or sine x equals 1/2, right? So I'm going to put that down. So, or sine of x equals 1/2. And again, look on your unit circle for all the values that give this. So theta is either going to equal, for the cosine values, we can have pi over 2 or 3 pi over 2, right? And for the sine values, we're going to get pi over 6 or 5 pi over 6. And these are all the values that work, okay? So our next example, we're going to use an identity to solve the equation, right? So because of this minus 4 term, we cannot factor out anything here. And so we're going to need to transform this. We're going to need to change this, right? Because we want everything to be in terms of sine of theta so that we can factor, right? So do we have an identity that can help us with this? Try to look at your equation sheet and figure that out. So I know that the Pythagorean identity says that cosine squared plus sine squared equals 1. Which means that cosine squared is just equal to 1 minus sine squared. And so I'm going to put that in. So this is 1 minus sine squared theta. And then these are the same, plus 4 sine theta minus 4, right? Equals 0. We're going to add everything up here. So combine like terms, we're going to get negative sine squared theta plus 4 sine theta is equal, minus 3, right? Because this 1 here is equal to 0. And now we're going to factor this. So I'm going to use my AC method. We have negative 1 times negative 3 is equal to 3. And we want to find two factors of 3 that add up to 4. So that's negative 1 and negative 3, right? Or excuse me, just 1 and 3. And so we're going to get negative sine squared theta minus sine of theta, plus sine of theta, excuse me, plus 3 sine of theta minus 3 equals 0. From this, we can factor out a negative sine theta term to get sine of theta minus 1. And from here, we can factor out a 3 to get sine of theta minus 1. And then we can take out this like term right here to get sine of theta minus 1 times negative sine theta plus 3, right? So in this case, either sine of theta equals 1 or sine of theta equals 3. And we don't care about this one, because sine only goes from 1 to negative 1, right? And so we're only solving on the unit circle for this. Did I make sure? Yeah, on 0 to 2 pi. And this means that theta just has to be pi over 2. And we're done, and that's the answer to that problem. So, on to some new topics, or sort of new topics, right? For sine of theta, we're going to have to start thinking about generating new solutions, right? So if we use the inverse sine not theta. So the inverse sine of some value, right? So it wouldn't be an angle, but like it would be opposite of our hypotenuse, right? So the inverse sine of like the opposite of our hypotenuse will give us some angle, right? And if this angle works for this one, so we're saying that excuse me. So the sine inverse of some value, which is actually going to be like a height on the unit circle, right? So if I go over here, it might just be better to explain on the unit circle, right? So if I have this unit circle, right, and I have this angle here, and it's at some height, right? So this is the height it's at, right? Then it makes some angle right here, right? So this is the angle that it makes. It's actually going to have the same height right here, right? And so this angle right here is also t, which means that this full angle here is going to be pi minus t, right? So for sine, if t is a solution, so is pi minus t, right? So looking back at our previous ones, if we're solving for sine of theta equals 1/2, right? We'll either get theta equals pi over 6 or 5 pi over 6, right? But notice that 5 pi over 6 is just pi over 6, or excuse me, is just pi minus pi over 6, right? Verify that yourself. And so this is like the formula that we're going to use to find extra solutions with sine, right? Because sometimes we'll have to use the inverse sine, and that's only going to give us one value, and usually we're going to have to find two values, okay? So on the other hand, for cosine of theta, if t is a solution, then so is 2 pi minus t. So I'm going to copy this over. We're talking about cosine now, right? And we have this angle right here, this angle t, and it lies at some width, right? So if I can erase this, it lies on like this width, right? So, well, then this angle right here is gonna have the same width, right? So right here, we're gonna see that it's at like the same width, the same x coordinate. And this angle is t counterclockwise, right? Which is an angle of negative t, but we have to add 2 pi to that to get it back on a unit circle. So if t is a solution, so is 2 pi minus t, right? So that's going to be our two solutions. So again, if we were thinking back to our previous problem, we have the cosine of theta is equal to root 2 over 2, right? Our first solution could have been theta is equal to pi over 4, right? And then if we looked on our unit circle, a second solution would be 7 pi over 4, right? But we know that 7 pi over 4 is just 2 pi minus pi over 4, right? And so that kind of identity makes sense, right? So basically, if you're given a t value that works for cosine, an angle that works for cosine, then 2 pi minus that angle will also be the same. And for sine, it's pi minus that. So for complicated problems with sine inverse and cosine inverse, we're going to use the quadratic formula to find all values of sine theta or cosine theta that we want. We're going to use sine inverse or cosine inverse to find the first value. And if needed, we're going to add 2 pi to get in the range of our unit circle. So for sine, we're going to take pi minus x for all values found in our previous part. And for cosine, we're going to take 2 pi minus x for all values found in the previous part. That might sound like a lot. So I'm just going to go through an example, right? So keep this in mind. So our example is going to be to solve, I'm going to move this over. Our example is going to be to solve 9 cosine squared of theta minus 1 equals 0. So we can find that cosine squared of theta equals 1. 9 cosine squared of theta equals 1, right? Which means cosine squared theta equals 1 over 9, right? But then this has two solutions. So we can either have cosine of theta is equal to the positive square root of 1/9, right? And the square root of 1/9 is just 1/3, right? Or we can have the cosine of theta is that negative root, right? Because then cosine squared would still be 1/9, so negative 1/3. And so we're going to have to solve this. So if you put this in your calculator, right? So now we don't have a unit circle value that's going to work. So this means that theta is equal to cosine inverse of 1/3. And if you do that in your calculator, and make sure your calculator's in radian mode, right? You're going to get 1.231 radians. And if you solve this one, if you put this in your calculator, so if you say that theta is equal to cosine inverse of negative 1/3, then you're going to get, you're going to get 1.911 radians. So we just found our first two values, right? So these are between 0 and 2 pi, right? These are fine. So now we're going to have to find two new values from this. So because it's cosine, we're going to take 2 pi minus 1.231, and that's going to equal minus 1.231. That's going to equal 5.052, excuse me, 5.052 radians. And for this one, we're going to take 2 pi minus 1.911 radians, and that's going to give us 4.372 radians. And then these would be all of our solutions, right? And there we go, we're done. So we only have a few problems to go, right, guys? So I hope this made sense, right? So basically what we're doing is we're using cosine inverse on our calculators to find one value, right? And then we're using our rules to find one more value with that, because there's always going to be two values unless it's on the unit circle, unless we're doing like sine is equal to, say, 1 or negative 1. You're looking for two values. You're going to apply this rule to get another value. And you're going to do that for all of the possible like solutions, right? So if cosine theta is 1/3 here, then if we square it, it's going to be 1/9. And so 9 over 9 minus 1 is 1 minus 1, which is 0. So that solves it. And if cosine of theta is negative square root of 1/9, or negative 1/3, then if we square it, it's going to be still positive 1/9 because it's squared. And we're going to still solve that equation. So moving on to this next one, right? How would you solve this? Try as you might, you cannot factor this. So we're going to need to use the quadratic formula, right? So x is equal to negative 1, negative b, plus or minus the square root of b squared, which is 1, minus 4ac, so plus 4, all over 2a, which is 2. We're going to get x is equal to negative 1/2, plus or minus the square root of 5 over 2. And if we put this in our calculator, this means x is either equal to plus the square root of 5 over 2. X is either going to equal 0.618, or x is going to equal negative 1.618, right? So what if we had something like solving sine squared theta minus 8 sine theta minus 1 equals 0 on 0 to 2 pi, right? We're going to use the same tactics that we did here. We're going to say, okay, sine of theta is equal to negative b, so 8, plus or minus the square root of b squared, so 64, minus 4ac, so plus 4, all divided by 2a, which is 2. And so sine theta is 4 plus or minus the square root of, 70 over 2, right? But we know that 70 is equal to 4 times, oh, never mind. No, it's not. Ignore. Oh, I can't do math, that's why. Oopsie. So 64 plus 4 is in fact 68, not 70. And we know that 68 is the 4 plus or minus the square root of, 68 is 4 times 17 over 2. And we can factor this 4 out of the, out of the radical. So we're going to get 4 plus or minus 2 root 17 over 2, which is 4 plus or minus the square root of 17. You could have also put this in your calculator, or even this right here. I don't need you to find the like radicalized version, but I know that some people were like confused on how to rationalize to reduce square roots. So you're just going to find, so 4 is 2 times 2, so we can factor a 2 out. but let's keep it simple, right? So sine of theta is equal to this. If we solve for this, so if we put that in your calculator, we're going to get sine theta is either equal to 8.123 or we're going to get sine of theta is equal to negative 0.123, right? So we can ignore this one, right? Because it doesn't make sense. And we're going to take a look at this one, right? So when does sine theta equal negative 0.123, right? I'm going to take the sine inverse of negative 0.123 in my calculator. And that's going to give me, oh, that's funny. It's going to give me negative 0.123. So it's actually interesting. I'm going to use my rules that I got up here, right? So we found sine inverse to find the first value. And we need to add 2 pi to get it in range, right? Because we can't have a negative value. So adding 2 pi, we're going to get 6.160. And this is our first value. And because it's sine, we're going to take pi minus that value. So pi minus 6.160 well, that's going to be negative 3.018. But again, this is not between 0 and 2 pi, so we have to add 2 pi to get it back to our interval. And we're going to get 3.265. And these are our two values that work for this, right? And you can just confirm if I go ahead and plug that into my calculator. So I have sine of x squared minus 8 sine of x minus 1. And I'm going to graph that, and I'm going to put in 6.160. And yes, those do appear to be the zeros of my function, right? So it is kind of tedious, but it's not super hard, right? So all you're doing is you're treating sine of theta like x. So this is like x squared minus 8x minus 1. And you're using that quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So using that, you're going to get two values out, and some of them may not work, right? So this one was above 1, so it didn't work, but we also got this value. So sine of theta is negative 0.123. We can then plug that in our calculator using the sine inverse to find one possible angle. And once we found the angle, it was sort of outside of our range of 0 to 2 pi, so we had to add 2 pi back to it, 360 degrees, to get an angle in our range. And then we used our tactics from before, right? Like the way that sine of pi minus t is the same as pi of t, right? To get another value and then transform that back in. So that's all we had to do. It does seem a bit involved, but as you practice these, it'll get a lot easier. Good luck, guys. You got this. You're almost at the end. Like, we only have one more week to go. So proud of all of you guys. I hope this video was at least a little helpful. Bye-bye.